Hello, scientists, and welcome to Ms. Sessa's virtual classroom. Obviously, we're doing things a little bit different tonight, and I've recorded this for you guys so that we can go over what we did in class and also sort of move on so that you can complete your homework. A few things I just want to say before we actually get started is you can follow along with this video. I've posted the slides on Canvas as well, but I'm going to ask you to pause the video at some points so that you can actually do the activities. Obviously, you can not pause the video and just move on, but you won't get as much out of it if you don't pause it. So this is what I call being an active participant in our virtual classroom. So when I ask you to pause things, really do pause things so that you can figure it out for yourself, and then we can go over it together and see if you've gotten it correct. And then you can ask questions in class. So make sure you're taking notes. You will need your notebooks. We'll be writing things down. So if you don't have your notebook, pause this video right now and get your notebook. Okay, so this warm-up should look familiar. You did have this today in class. So make sure you have that in your notebook. So this is what we did in class, and so I want to go over it so that we can move forward and sort of understand what's going on. If you need more time with this, now's the perfect time to pause the video, do the atom builder activity, and answer these questions in your notebooks. If you finished it, great. We can just move on and we'll go to atom builder. All right, so here is, oh, I already have it up here. Okay, I'm going to click symbol so that we can sort of see what's going on. So down here, I'm actually going to click stable, unstable. I'm going to keep this as orbitals instead of clouds. You can do whatever you want, or you've already done this. So the first thing, or the first question is, what do the symbols mean? We don't have any symbols yet, so I'm just going to put in some protons. Here, put in some neutrons, maybe electron, who knows. So we have a symbol here, it says H. Here it says hydrogen. I'm going to add a few more things. Here we have He, and this says helium. Going to add a few more things. Let's see what goes on. Oh, we have Li here. We have lithium, and this shaking a little bit. So here I can see that these letters, this symbol, we call this the element symbol, stands for the specific element. That's really all I was looking for. So understanding that these letters stand for an element. And you can see we have both element symbols that have two letters. So this is capital L, lowercase I. When we took away these two, we have just H, just one capital letter, standing for hydrogen. Okay, so again, we'll kind of go over all of those things, but that's what I wanted you to get for number one. So then the second question says, how does a proton change an atom? So I'm going to reset all of these things so that we can just look at our protons. So the first proton, or I have one proton, and I have hydrogen. Okay, I'm going to add another proton. Okay, when I've changed that, I now have helium. When I've changed it again, right, every time I add a proton, I get a different element. Okay, so let's look, what if I add a neutron, right? We still have the same element. If I add an electron, same element. So from here, I'm going to say the protons tell us what specific element we have. So if I change the proton, I change the atom in general. The whole thing, I've changed it. So now it's saying, how does an electron change an atom? So if I add some electrons, okay, nothing I can see here, but I can see something over here going on. Okay, so as I add electrons, okay, this is becoming more negative. Okay, this isn't changing and this isn't changing at all, but this is. So I can conclude that electrons make an element more negative. It changes the charge, okay? Doesn't change anything else, it just changes the charge. Okay, I'm gonna reset this, add a proton, okay. So now it says, how does a neutron change an atom? So let's look at these. Okay, I have a neutron, I have another neutron. So far, not much is changing. Over here, this is changing. So if I take it away, so it must mean that it increases the atomic mass. Oh, I also didn't click this. So it also tells us if the element is stable or unstable. So those are the two things that neutrons do. So it adds to the atomic mass, and it also makes it stable or unstable. I also forgot, when we look at protons, it also changes the mass here. Okay, so the only thing that changes the mass are the protons and the neutrons. The neutrons tell us if it's stable or unstable, and the electrons change the charge. Okay, so hopefully that makes sense. And then it says, the last question, what do the numbers on the symbol mean? So we have these numbers here. This is telling us the charge, so if it's positive or negative. So here if I add some protons, oh, we actually do change the charge. So protons are making it more positive. It's also changing this here, whatever this number is, and it's changing the mass here. So as I add more protons, right, we're going along the table here as well. We're getting a different element. Okay. If you have questions about this, please write them down in your notebook now so that we can go over them the next time I see you, which will be on Monday. All right, let's move on to our next slide. So this is just going over what your homework is. So right now you're watching the Atoms intro lecture. Excellent, you're on the right track. You're taking notes on the lecture in your notebook. Then you're going to do the practice problems. You actually don't need to do it in your notebook, so I can change that. You can do them right on the paper. Come to class Monday with questions, and then your homework on Monday will be the second half of those practice problems, and I will collect them. So I'm going to change this now. The practice problems on your paper. Excellent. All right, so here's where we're going to start taking some notes. And you can title this Intro to Atoms or Intro to Elements in your notebook, and then put that in your table of contents. So the first thing we have is elements. So we just saw from that atom builder activity that elements are represented by a letter. So for example, like C for carbon. So make sure you write that down somewhere. And then what I'd like you to do is to pause this video, follow along with your slides, and I want you to match the elements with their symbols. You can use your planner. Your planner has a periodic table on the back, or you can go to ptable.com, or there's a periodic table on Canvas under class resources. But what I want you to do is just to match them in your notebook. And then what do you notice about these element symbols with their element names? So what's going on there? Okay, so pause this video and then we'll come back and go over it. So again, this is where I'm talking about being an active participant, actually doing it, using your brains, using that muscle so that you can sort of figure it out and then ask any questions that you have. Okay, don't be a passive listener, be an active listener, an active participant. Okay, pause the video, get these in your notebook. Okay, hopefully you've finished that, and hopefully you've noticed some things about these elements, right? So hopefully you found we have hydrogen here, right? That's just H. But then what did we find out about potassium? What is that element symbol? So hopefully with your research you found that it's K. Oh, you can't really see it, but it's K. So not all elements are their first letters. Okay, that should be something that we notice. What about gold? Okay, gold symbol is AU. Again, nothing with the English name. So a lot of these elements come from Latin or Greek. there could be, so there was already maybe like a G element, or they didn't want that. Whoever discovered the element gets to name it and come up with the symbol. And so they decided to use the Latin or Greek, so we have AU. Neon we have as Ne. Boron is just B. Sodium is Na, that's a really important one. And then chlorine is Cl. So this is my pet peeve, okay? You will never see Ci together. It is never Ci. It is always Cl. The elements carbon and iodine do not bond, so it will never be Ci. It will always be Cl. I will absolutely correct you when you tell me it's Ci, because this is one of my pet peeves. We use chlorine a lot, so just get used to it now. Say it in your brain. Cl, Cl, Cl. It's Cl. And that brings me to the next thing. Whenever we are writing elements with two letters, the first one is capitalized and the second one is lowercase. This is really important when we do get to compounds and molecules and we're putting together elements. We really need to have one capital and one lowercase for that one element. So you should never see Ne with a capital E, okay? That could stand for something completely different, okay? Hopefully you've heard my soapbox and understand that. Those things are very important. Moving on. So elements, we said, are defined by the number of protons, right? That was one of the questions and answers for our atom builder activity. So where do we find protons in an atom? What did you see on that atom builder? Where were they located? If you don't remember, you can go back to the atom builder, pause this video, and take a look. Where did we find those protons? Okay, hopefully you said in the middle of the atom, okay? We call that the nucleus, okay? All right, next. I'm gonna skip this one for right now. If you really wanna know how they've discovered atoms, you can go look at the simulation, but it's not that important for us to know, but it is kind of interesting, so that's up to you. All right, I want you to absolutely copy this into your notebook. Again, if you have to, pause the video so that you can copy this down. But the things that you should know, right? This is our symbol, our element or atomic symbol is what we call it. It's a capital letter or a capital letter and a lowercase letter, and it stands for that element. Up here, the integer number, that is the atomic number of our element, and it's the number of protons, okay? You can see that I kind of blacked out this part here because that said number of electrons. In a regular atom, the atomic number will tell you the number of protons and the number of electrons. But when we get to ions, which means it doesn't have the same number of electrons, right? That atomic number is not the number of electrons. So what I want you to know is that your atomic number is your number of protons. If you change the protons, you're changing the atom. You're changing the element. So that number always, always, always corresponds to that symbol for that element. Okay, so protons always tell you what atom we have. Down here, this decimal, that's our atomic mass. And so that's how much it weighs. And it's in AMU, which is just atomic mass units. We don't have to get into what that means. Just know there's an atomic mass unit, and the atomic mass will always be the decimal. So again, if you need to pause this, pause it so you can copy this down into your notebook. Otherwise, I will move on. All right, so here we have the element carbon. And what I want you to do again is pause the video and try and figure out what is the atomic mass of carbon. Using the notes that you just copied down, what is the atomic mass for carbon? What does the atomic mass measure? And then how might we find the number of neutrons? Okay, so pause the video, use your notes. What is the atomic mass of carbon? What does the atomic mass measure? And how might we find the number of neutrons? And this second one, right, you have to go back to atom builder again if you're unsure. Try and figure out what the mass measures. Okay, write this down in your notebook. All right, so hopefully from your notes you remember that the atomic mass is always the decimal. So here it would be what? Yes, it's the 12.0107. That's the atomic mass. And then when we were on the atom builder activity, we saw that the atomic mass changed when we added neutrons and when we added protons. It did not change when we added electrons. So we're going to say electrons have no mass. They're super, 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 super tiny compared to a proton and a neutron. So the atomic mass measures the number of protons and neutrons. Okay? So then my question was, how might we find the number of neutrons in an element? Well, if we know the mass is protons plus neutrons, and we know that the atomic number is just the protons, we can do some subtraction to figure out the number of neutrons. Okay? So here, I think the next slide, yep, we have them here. Protons plus neutrons are the atomic mass. And so we can use some subtraction. To calculate neutrons, please put this in your notebooks. Okay, it's what I said, but just written out. So pause the video if you need to. Atomic number is your number of protons. Atomic mass is your number of protons plus your number of neutrons. So in order to find the number of neutrons, you take the atomic mass, which is the decimal, but we will round it to the nearest whole number, minus the atomic number will give us the number of neutrons. Okay? Again, pause if you need to, otherwise I'm moving on. All right, let's go back to this one. So we know that the atomic mass is 12.0107, but we're rounding that to 12. That's our mass. Minus 6, which is our atomic number, gives us 6 neutrons. Does that make sense? 12 protons plus neutrons minus 6 protons gives us just 6 neutrons. Okay, we're going to do another one here. So here we go, we have oxygen. So calculate, tell me, how many protons does oxygen have? How many electrons? And how many neutrons? So again, pause this video if you need to. Since I can't really show you, I can't write on this, to sort of help you figure it out. Okay, so how many protons does oxygen have? How can we figure that out? Remember, we said the atomic number tells us how many protons we have. Okay, so here we have 8 protons. How many electrons do we have? Well, unless I tell you otherwise, you're going to have an equal number of protons and electrons. So here we also have 8 electrons. But how many neutrons do we have? Well, we are not really sure. So we have to take our atomic mass. Our atomic mass here, right, we're rounding it to 16. We want it to the whole number. So atomic mass minus our atomic number, 16, here minus 8, gives us 8 neutrons. Questions? If you have a question, write it down, please. We will do it in class. All right. So now I want you to do 2 more. How many neutrons does fluorine have? How many neutrons does neon have? You need to use the periodic table. There's one under Canvas under class resources, but I've also put it right here. Okay, so using this, I want you to calculate the number of neutrons for fluorine and neon. I'm not going to give you the answers for this one because we'll probably do it in class, but I want you to try it beforehand. Okay? So, your homework are the practice problems part A that I gave you in class today. That's due on Monday. We're going to go over any questions you have, and then part B will be due the next time I see you, which We're not sure yet. Maybe it's Tuesday, maybe it's Thursday. We'll see. You will have a quiz on calculating protons, neutrons, and electrons. You'll also have a quiz on element symbols. So you'll need to memorize the atomic symbols for the elements 1 through 36. That's because we use those a lot. They're pretty common, and so if you have to look them up all the time, it makes it a lot harder. So that's the only thing I'll probably ask you to memorize. Everything else is sort of like application. So if you have any questions, please write them down so that we can go over them. Or you can email me if you're stuck on other things. Or you can come to office hours, or come to class at some point, and we'll go over them. You can just email me to see when I'm free. I'm free pretty much all day. Friday, Monday I'll be teaching you guys, but then in the afternoon I'm free. So whenever you're available, I'm available, and let me know so that we can understand this and move on to some more fun things. All right, thanks.